matrices and determinants. This is what we're going to look at. What are matrices? Matrices is just an array. Don't want to write too much note because that will waste time. An array of numbers. For example, look at this. This is an example of matrix. It is written in rectangular box. So the horizontal part is called the what? The row. 2 and 4 are called the row, while the vertical part is called the column. 2, 5, 4, 6 are called the what? Column. So for you to identify a matrix, you use m by n, where m is the number of row and n is the number of what? Column. Take note. So we have some operations used in this case we see 2 by 2 because it has 2 rows, 2 columns. All these are very elementary. We have some operation used in matrices. We have the addition. So let's say we have question, we have something like this, plus. So what you do is that you add this row, the position of this one to this one. So 2 plus 5 is what? 7. 4 plus 6 is what? 10. 5 plus 7 is what? 12. 6 plus 9 is what? 15. Take note, they must be of the same what? Order before you can add. That is the most important. You will notice this one is 2 by 2. This one is also 2 by 2. They are the same. That is why we can what? Add them. But if they are not the same, you can't add. What I mean is that if this one is 2 by 2 and this one is nothing, it's not 2 by 2, it is 2 by 3, then you cannot add. Take note. Same thing works for subtraction. If it is subtraction, you just say 2 minus 5 minus 3, 4 minus 6, put. So that is that. Then we have the multiplication. Multiplication. For you to multiply, you take this, use this one to multiply this, and use this to multiply this. So you say 2 times 5, 10, plus 4 times 7, 28. Then 2 times 6, 12, plus 4 times 9, 36. Then 5 times 5, 25, plus 6 times 7, 42. 5 times 6, 30, plus 6 times 9, 54. So what is 10 plus 28? 38. 12 plus 36, 48. 25 plus 42, 67. 30 plus 54, 84. So for you to multiply two matrices together, I've given you for addition and subtraction. I said for addition and subtraction, they must be of the same order. But for multiplication, the row, the column of the first matrix must correspond to the row of the other matrix. This is what I mean. You can only multiply two matrices if they are in this form. You notice this one is m by n. That means for the first matrix, this is m by p. You notice that this one and this one correspond. If they correspond, you can multiply. Or if they don't correspond, you can't multiply. Look at this one is 2 by 2. This one is what? Also 2 by 2. It's not because they are the same. It is because this column here corresponds to this row. That is why we can multiply. Let's look at another question. Can we multiply this? Let's see. This one, what type of matrix is it? Let's try to identify it, because that is the first step. This one is 2 by what? 3. Why? Because I have 2 rows and 3 columns. What type of matrix is it? 2 by 2. Is the column here corresponding to the row here? No. Meaning you can't multiply. See, it makes sense. 2 times 1, 2. 5 times 3, 15. Is there any way I can multiply 6? No. So this one can't be what? Multiplied. So let's look at another example. Can we multiply this? Let's check. It seems here. Look at it. We have 3 rows here. That is 3 by, how many columns do we have? 1, 2. We have 2 rows, and how many column? 3. You notice the column here corresponds to the row here. That means you can multiply. So the same way of multiplying still applies. They just say 1 times 2 plus 2 times 7. That is 16. So you do the same. 1 times 5 plus 2 times 8. 21. That is 5 plus 16. 1 times 6. So that is how you do that. So in the next video, we are going to look at some other interesting thing about matrix. That is the inverse of a matrix, the adjoint, and all. Thank you for watching this.